First, I want to say thank you guys so much for showing up. This is awesome. There's a lot of great speakers here, and you guys chose to hang out with me, so hopefully it's not disappointing. I'm going to go ahead and take the obligatory Twitter picture thing of all you guys, so here we go. Smile. Great. Awesome. So I'll explain why Jerry's up here in a second. For now, I need 2 volunteers who have laptops. So first volunteer needs to go to this link. Who will do this? It's going to require that you play something 25 minutes into the talk. It's a time warning. Who will do this for me? All right, great, awesome. So you pull that up. While you're pulling that up, I need another volunteer to go to this link. And what this person is going to be responsible for doing is they're going to play this sound bite when I talk too fast. Because I've given this talk before and everybody says, you talk too fast. We're not trying to watch this on 2x, right? So that's what the second volunteer is going to do. Who's going to do that? Awesome. Okay, great. Okay, is the first link's been pulled up? Can we get a sound check on that? Yep. Yeah, please. All right, running out of time. Cool. Sound check on the other one. You gotta make it louder. Can make it louder? Okay, you're fired. Next person. Sorry, I appreciate it. A for effort. Okay, great. You're gonna do it. We're not gonna do the sound check because we gotta go. Okay, so let's get back to Jerry. Parks and Recreation fans, anyone? Anyone? Okay, yeah, good, we have some people. Okay, so if you don't like Parks and Recreation, you need to know that Jerry he's a well-intentioned guy. He's really nice, but he's kind of clumsy and sometimes he's misguided and does terrible things, right? And that's why he's on fire here. And I had a Jerry-like moment recently as an Android developer where I wanted to do something nice. I had good intentions, but it didn't turn out well. And the nice thing that I wanted to do was introduce Dagger into the code base. Right, so I thought that the team would be really appreciative of the Dagger work that I was doing. And this happened about 2 years ago. Instead, what happened is everyone hated me, kind of like Jerry in the show, right? This talk is not about not using Dagger. If you were hoping to see that, there's still time to join another session. I actually like Dagger a lot. I've looked at Coin, I've looked at the other alternatives, and Dagger's great. This talk is called Dagger 2, 2 years later, because it's about the lessons that I've learned 2 years after kind of starting to use Dagger at my company. So the 2 years here is key. And there's this really great quote about software engineering that I want to open with to kind of frame why I think this 2 years part is important. So I'm going to read this really quickly. In software, feedback cycles tend to be on the order of months, if not years. It's during the full lifetime of a project that a developer gains experience writing code, modifying it, testing it, and living with previous design and architecture decisions during maintenance phases. With everything I've just described, a developer is lucky to have a first try of less than 6 months. So we see a lot of talks on Dagger or blog posts on Dagger. It's like, oh, how do you use Dagger? What's the API surface? But you don't see a lot of talks or a lot of blog posts on, hey, we made this decision. Here are the consequences 6 months out, 1 year out, 2 years out. Probably because a lot of us are changing jobs every 2 years. But that's really what this talk is about. We made the decision. We've lived with it for a couple years. What are the lessons that we've learned? Specifically, what are the lessons that we've learned to help make Dagger more easily digestible for new developers that are getting spun up on the team? So let's focus in on the years part of this, and let's go back a few years. So let's go back to the year where this movie came out, and the year where this selfie was taken, and the year where this happened. Does anybody know what year this is? It's actually on this slide. Yes, good. Okay, good. Yeah, so let's go back to 2014 and to a talk that Jake Wharton gave about Dagger 2. He's really proud about the simplicity of Dagger 2. Here's what he says. The entire public API of Dagger 2 is right here on this single slide, not this slide, obviously. So the only hard part about using Dagger 2 is really understanding the fundamentals of dependency injection and the concept of how to do each of these individual things, how to provide dependencies, how you request dependencies, and then the component interface of how you link the two together. So Jake Wharton's really excited about Dagger 2 because he thinks it's even simpler than Dagger 1. That's back in 2014. let's fast forward to the end of last year and look at this comment from Don Felker on Fragmented. So here's what he says. He says, when Dagger 1 came out, I felt like it was just simpler, and then Dagger 2 came out, and it felt like it got really complicated. And Kaushik in the same episode says, I think there's a shared understanding that there's something wrong with Dagger 2. Something's not working, right? And this is in a recent episode of Fragmented. So something's not working. Why? Let's talk about that for a second before we get into the solution. And the reason that I think it's useful to talk about this is this, a problem well put is half solved, right? This is John Dewey, he's a philosopher. I like philosophy, so hands raised emoji. And then another reason why it's worth talking about why is there's not like a gotchas section in the Dagger documentation. They've made some improvements to it recently, and it's great. But if you're going to adopt a Dagger for your team, you're not really going to get a preview of some of the challenges that you might run into. And so by going over some of those potential gotchas, hopefully it'll be helpful. Before we get into that, who's already using Dagger 2? Oh, man. Interesting. Okay, I did not expect that. If you have been using Dagger 2 for longer than 6 months, raise your hand. Okay. If you've been using Dagger for longer than a year, raise your hand. Wow, so you guys have been doing this already for a while. Hopefully this talk is still interesting. So, yeah, maybe you guys were hoping that I would say don't use Dagger. Okay, so that'll help me tailor things a little bit. But so we're going to go through, and I think you guys will relate to why Dagger is challenging since you guys are familiar with it. But let's look at a quick example, and we'll be able to fly through this because you guys know what you're doing. So this is a screen from the Google I/O app. And let's really quickly look at how you might use Dagger to implement some analytics on this screen. So here's a piece of code, and the code that matters here are these kind of analytics calls on this analytics helper. I see some squinting. Sorry, it looks like the font isn't big enough. But basically, you have this analytics helper that's been injected into this fragment. This is actual code from the Google I/O app, by the way. So you need to inject it. Using Dagger, and so let's kind of use this as our working example of some of the things that you might run into if you're a new dev working with Dagger. So if you're assigned this task, and let's say you don't actually have this dependency injected, in the best case scenario, all you're going to have to do is go to the analytics helper class declaration and throw on this @inject annotation, right? So that's not too bad. Great. And so you're done with the kind of providing dependencies part of the equation. Now, for the requesting dependencies part of the equation, you're just going to add an @inject to a late init field in the class. But how do you actually make sure that that field is filled with an object when you actually want to use it? So in order to answer that question, you kind of are already faced with maybe the first question that you might have to ask yourself when you're working with Dagger 2, and that is, do I want to use Dagger Android, or do I want to write this, kind of, I guess it's like 2 or 3 lines of boilerplate to get a component from the application and inject into this fragment or activity. Actually, the Dagger docs call this out as like one of the reasons why Dagger on Android is hard. So one of the very first things that you have to do, like if you're just starting to work with Dagger, is do something that the docs say is hard. And so that's kind of a bummer. So that's one reason why it's kind of tricky. Let's kind of keep going with the example and modify it a little bit. Suppose that the analytics helper is actually a library class. In that case, it gets a little more complicated. You guys know this because you can't just add an @inject annotation on the constructor. You actually have to have a provides method. If you have this provides method, you kind of have to wonder, okay, well, what module does this provides method go in? And that's another question you might have to ask yourself when you're getting spun up. And not only that, when you look at this method, there's another question that you kind of have to ask yourself, and you will get at that question by asking, how could this code be improved? Does anyone know? So you could improve this by using binds instead and making it an abstract function, right? I see some head nods, so some of you knew that. So that's another question that you kind of have to ask is like, well, should I use binds or should I use provides? And if I'm working in Kotlin, it's a little more complicated because you have like some JVM static annotations that you have to add. And there's some concerns about mixing non-static with abstract methods. And so that's another question that you have to ask when you're trying to do your Dagger work. So you could replace that with binds. Here's another question you might have to ask. Does this dependency need to be scoped? If so, which one? So, going back to this code, you might have, your binds annotated function, and you might add, okay, this needs to be singleton scoped. Another question you might have to ask, do I need a qualifier? If there's already, a binding in the graph for this type, do I need to qualify it somehow? So going back to this code, I might need to add a qualifier with a sad face emoji because I just wanted to get my work done, and now I'm shaving a gack. I'm 3 or 4 questions into figuring out how to get this thing wired up to Dagger. Another question you might have is, do I have any dependencies that are what I'm calling late bound? So things that are not going to be available at compile time when you're actually writing your modules out. So things that you would inject with like a binds instance or a factory or something like that. So that's another thing you might ask. And here's an example factory just so you can see what I'm talking about. And if you have any late bound dependencies, there's another set of questions you need to ask yourself. Should I be using builders inside of the component? Should I be using a factory, or should I be using assisted inject, which is a new thing that just came out, fairly new thing. So there's one more thing. If the dependency of the dependency is not in the object graph, then you have to go through this whole process over again. And so you can see, like, this is the list of things that you're going over when you're first getting started with Dagger if you have a task. And if you're not familiar with Dagger, you can understand why people might be upset. And it actually gets worse. So let's look at a couple of other cases. And let's focus in on this, if I can't just add an @inject to the constructor, what module does it go in? So another thing that makes it a little more complicated is the testing story with Dagger 2. And of course, this is one of the key advantages of dependency injection, but it actually requires a little bit of upfront design of your modules in order to take advantage of the testing aspects of Dagger 2. And so that complicates the situation of where you should be putting these dependencies. And so let's add that question. And then let's say that you have you're working in a legacy code base and you have an object around that's like this, right? Like, don't instantiate this until this other thing happens. It's kind of like, shady, right? Not great to have code like that, but you might have some code like that. And here's actually an example from our code base. So we have this database class. It needs to be initialized. And in order to be initialized, it needs to have a logged in user. Terrible code, but there it is. That's the key line. And if you have something like that, well, then you need to ask, okay, do I need like a lazy of type T or a provider of type T? So this is another kind of question you might have to ask yourself. So hopefully it's pretty clear, why people are complaining about Dagger. Presumably, this room's kind of full attendance is also a testament to some of the concerns about it. And so we've covered that, and we can kind of see, why it's a problem, and hopefully that's a good starting point for working through some solutions. And also, for those of you who haven't started Dagger yet, hopefully this checklist will be a nice thing that you can look out for your team if you're kind of the person that's trailblazing Dagger for your team. So that's why. Now, all of this has basically been recognized by Google. In Android Dev Summit a couple weeks ago, they had this session. They've posted a Medium blog post where they talk about the cost of using Dagger, right? And there's this graph that looks like this. They've got the manual DI graph, or the manual DI line. They've got service locators, and then they've got Dagger, right? And they're like, Dagger's, the winner if you're working with an app that's sufficiently large. And so they've recognized this cost, and really the rest of the talk, what I want to do is I want to try and see how can we get more mileage out of manual dependency injection, and then how can we lower that initial cost to Dagger. So that's what the rest of it's about. So let's talk about kind of getting more mileage out of manual dependency injection. And this is actually going to take us into some maybe dicey, controversial areas, but hopefully it'll be interesting. So in the Android Dev Summit talk, they made this kind of bold claim. You should always apply DI principles to your app. And depending on how you interpret that, that's a pretty strong claim, right? I'm actually going to, does anybody know what this is? Recognize this picture? So this is like Galileo and the Catholic Church, right? He's a heretic, and I'm going to be a heretic. So instead of saying like you should always apply DI principles to your app, I would encourage you to ask, is DI worth the cost here and now? and that might sound crazy, but like even somebody like Martin Fowler, like he's always mindful of trade-offs. So he has this great quote from a podcast with Kent Beck and DHH. And he says, I'm actually always suspicious when I'm writing up a pattern or a technique if I can't talk about the reasons when you shouldn't use it and the trade-offs against it. If I can't find arguments against it, then I'm worried I'm not analyzing things properly. This applies to dependency injection too. And so I think it's worth considering not kind of doing DI by default sometimes. And again, this will get us more mileage out of doing manual dependency injection. So let's talk about what this cost is of dependency injection. I think we're all pretty familiar with it, but let's go back to this example really quickly. So looking at the dependencies that are necessary for this screen, we see that there's this use case, which depends on this repo, which depends on this data source, which depends on some other stuff. And when you look at the actual code that's used for wiring up these dependencies, if you weren't going to use something like Dagger, it would look like this, but actually that's not right. It would actually look like this, and actually that's not right. I got tired of writing out the code manually for wiring up all these objects, and so that's the cost that you're paying for when you're doing dependency injection, as opposed to just having something like this. If you want your view model, you just new it up and you're done. And so that's the cost, right? Now, a lot of you guys are like, well, yeah, it's worth it, right? Because solid, like this has kind of been drilled into us. The D in solid, dependency inversion principle. What Uncle Bob actually says about this is clearly such a restriction is draconian. He's referring to the dependency inversion principle. If you have tried and true modules that are concrete but not volatile, depending on them is not so bad. Right? So he qualifies this a little bit. He still pushes us in the direction of using DI as much as possible, but he's not, it's draconian, right? To always use it. It leads to crazy code sometimes, and maybe it's not worth it. So that's Uncle Bob's view. Martin Fowler's view, people often quote these guys like they always kind of believe the same things. His view is actually slightly different, and he's actually not as excited about dependency injection as Uncle Bob is. So here's some code that Martin Fowler talks about in his seminal article on dependency injection. And here's what he says about the code. If I'm using this class for just myself, this is all fine and dandy. No problem. Like, it violates dependency inversion principle, I guess, but he's not worried about it. So some of you guys at this point might be wondering, well, okay, what about testing? Well, we can still solve that problem. If we go back to the screen and we think about the dependencies for it, and we look at some actual test code in the IO app. So here's some test code here. We can, you see that there's a view model that's being created, and that view model, we're going to call some methods on it, and that's how it's going to be exercised for the test. And the view model, of course, has a dependency, but we can kind of skirt, dependency injection a little bit by just using a default method parameter, right? So when in our application code, we can just new up a view model and not worry about the dependency. And then the test, we can actually have a separate dependency, a test double that we would use just for stubbing or mocking purposes. So application code looks like this, but the test code would look differently. Now, some of you might be thinking like, it feels kind of gross, like I'm mixing application code with test code. But I would actually argue that if the only reason you're using dependency injection is to support testing, you've already mixed the concerns, right? You're already doing that. You're already mixing application code and test code. So instead of doing that in a way that causes this cost of complicating your calling code of the objects that want to instantiate these things, just don't do that and kind of give yourself the hook for the tests, but leave the application code simple. So great. So that covers kind of how we might get some more mileage out of manual dependency injection. Let's talk about how we can kind of lower the initial cost of using Dagger. And this is going to take us back to that list that we spent some time building at the beginning of the presentation. Let's see, time check. I'm doing good. Did somebody forget to play a warning? I think we're good. Okay. So let's talk about this kind of back half of the list. So I'm not going to say a ton about this, but what I will say is we ran into a lot of these things because this was kind of our thinking of how we would adopt Dagger. A lot of people, when they're adopting Kotlin, they do something similar, right? They were like, oh, we'll just, as we touch a file, we'll convert it to Kotlin as long as it's not too much effort or changes too many things. And we kind of did the same thing with Dagger. And that was a mistake. To explain why it was a mistake, I would like to introduce my nephew. He's very cute. My mom likes to tell the story of when he was really young. She was changing his diaper, and all of a sudden he started screaming, and she couldn't figure out why. And she looked up, and she noticed that he grabbed his hair and started pulling. And, motor skills are not great at that age, right? So he didn't realize that he was just causing himself a ton of pain. And that's kind of what we did when we adopted Dagger. We were like, well, we'll make these changes as we go. And like, even if making a change in a particular file or place in the code base is really painful, we're just going to do it, even if it hurts. And so I think my advice for like that back half of the list for making Dagger easier to work with is just let go. Just don't, if something is really hard, just leave it alone. And so this back half, a lot of times, the things here, they're kind of pushing you to use more advanced features of Dagger, and it can wait. There's a couple of reasons that I think it's good to do this. So one reason involves a quote from Joe Armstrong, I think this is great. So he says, if you're ever in a big project and you're trying to find out how it works, and you talk to people and they say, I don't understand how this works, but someone else understands, then you can be sure that you're in a project that's going to go pear-shaped. I'd never heard that expression before. I think it's wonderful. So what does this have to do with Dagger? So if you're working in certain parts of your code base and you're kind of forced to use more advanced features of Dagger before the rest of your team has done kind of the hello world of Dagger, you're going to be in this situation where you're the Dagger guy. I don't know how many of you guys are maybe the Dagger guy, but I think it's actually more helpful, speaking from experience, to have everybody kind of have a baseline of Dagger knowledge before you tackle the parts of the code base that require more advanced features. And it's basically for the reason that Joe's pointed out here. The other reason that it's maybe worthwhile to like let the advanced stuff lie and tackle easier parts of the code base is sometimes the more advanced features are actually indications of a smell in your code. And this actually is a part of the Dagger documentation. Specifically, they're referencing the provider of type T. They say basically, if you have to inject this, you might be doing something wrong. And actually a perfect example of this is the database code that I showed earlier, where it's like, oh, we have this weird object that we can't instantiate until this other thing. Like clearly that object just shouldn't be weird. And then we wouldn't need to use this provider of type T. And so we can stick to more basic features of Dagger 2. Great, so that's the back half of the list. Let's focus on these first three things. And what time is this done? I heard a murmur. 2? All right, we're doing pretty good then. I'm gonna take a breath. How are we doing? We doing good? We bored? Do we need to play a game real quick or something? We're hanging in there? Okay. We're gonna hear a funny sound in a second. That'll be good. Nobody's complaining about the speed. Awesome. So let's talk about this first thing in the list. This choice between Dagger Android or using the boilerplate. What is this boilerplate? Let's look at this for a second. So this is a part of, wow, that looks pretty blurry. You guys are really nice. I would have walked out. So this is the boilerplate that we're talking about for actually getting dependencies from these components. And one way of skirting the question of using, should I use Dagger Android or should I, figure out this kind of boilerplate stuff, is you could actually use Dagger components as service locators. Now I realize again that this is like, people are really scared of service locators, right? And there's even a section of the official Android docs now. This was recently added that kind of warns against the dangers of service locators. But actually, if you're using Dagger components as service locators, none of these things really apply, right? So the first thing is like, the collection of dependencies required by a service locator makes code harder to test because all the tests have to interact with the same global service locator. Not necessarily. If you're using Dagger components as service locators, it's fine. The next thing, dependencies are encoded in the class implementation, not in the API surface. This isn't true if you're injecting dependencies in a fragment or an activity. This is it's already the case that your dependencies are encoded in the class implementation, right? It's not a part of the API because the system instantiates the fragment or the activity. So you're already here. If you're doing Dagger, whether you're using it as a service locator or not, this is already true, and so doesn't really apply. Don't worry about it. And this last thing, this is true, right? There's a trade-off here where there actually is a disadvantage to using these Dagger components as service locators. But if you're trying to kind of lower the initial cost of using Dagger, the trade-off could be worth it. And it's something that I would certainly try if I was re-implementing Dagger on a team. Before some of you guys, I see kind of confused looks, so you might not be clear on what I mean by using Dagger components as service locators. We'll look at some code in a second. Before we do that, I just really quickly want to bring up Fowler on service locators. He says basically, I've often heard the complaint that these kinds of service locators are a bad thing because they aren't testable. That's another concern that people have about them. He says certainly you can design them badly to get into this kind of trouble, but you don't have to. So Fowler is like not necessarily against service locators. So let's look at an example really quickly. Thank you so much. That was beautiful. Great. So running out of time. So here's an example of using a Dagger component as a service locator. Let's say you had a Bluetooth component. I work at a Bluetooth heavy company. And so you have this component. If you wanted to access that component inside of an activity, you could just basically have an instance of that component inside of an activity or inside of an application class, grab it, and then call this this BLE method to get the dependency you need, and then start advertising or whatever. So this isn't that much better than having to worry about Dagger Android or @inject annotations, but it's a little simpler. It's a little simpler, and I've found that when people are first learning Dagger, the whole basically writing a method in the component interface where called inject that takes in the activity or fragment as a parameter is often confusing to people who are first learning it, and so this kind of avoids that. Like it's just a normal method call on a component, and you're fine. You don't have to worry about that. And then of course Dagger Android is pretty complicated, so you can just avoid all that. So that's something that I think can make things a little simpler. Okay, so I think this is a big problem, especially if you're working in an older code base where everything isn't organized nicely. So how do we make this better? So if I can't just add an @inject to the constructor, what module does this go in? This is a question that somebody has to ask. How can we make it easier for them to answer the question? One way to do this is consider avoiding needless interface implementation pairs. I know this is controversial, but we often see code in our Dagger modules that looks like this, where you have a binds method, and it's binding. This actually isn't a great example because this is a framework class, but you might have a binds method where you could have just used an @inject annotation on the constructor. And the reason that's problematic is because you have more and more of these binds or provides methods that somebody has to sift through in order to figure out where to put something. And I'm going to bring in these two guys again to talk about kind of the software engineering principles around this, because a lot of people default to using interfaces, and they actually even cite Fowler and Uncle Bob to kind of justify the decision. But Fowler is actually not a fan of this. He says, this isn't a technique that I've ever much liked. Using interfaces when you aren't going to have multiple implementations is extra effort to keep everything in sync. Although he says good IDEs help. Furthermore, it hides the cases where you actually do have multiple implementations. So Fowler is totally fine with just not using an interface for everything. You can just have, your one class, and then you can have a lot more cases where you just have an @inject on the constructor instead of an additional binds or provides methods in a module that somebody has to sift through. So yeah, I think that's worth considering. Alternatively, you could just depend on an implementation in a class that's actually requesting the dependency. That's another way to get around this. So that's that. Okay, let's talk about this testing part, because that also complicates the story around where these provides methods go in modules. And more specifically, the recommended way of doing this in the documentation is basically, actually we can walk through an example, but so you have a subclass of your application component that installs a different set of modules. That's what you see here. So test application component extends application component, and it installs this fake network module instead of the actual network module. And here's an example of how that looks. So the fake network module just provides this fake login service, right? So this is kind of the standard way of swapping out your dependencies for testing purposes in Dagger, but it requires some upfront design, because your modules, you need to be able to basically swap them out in that application component subclass. And so that just complicates the story on where things go. So there are a couple of alternatives to this. One is you could consider using late bound dependencies instead of these published modules, which is the name that Google gives for modules that will be swapped out for testing purposes. So instead of having the test application component subclass and the different modules you have to change, you could actually just have basically a factory interface inside of your application component that takes in the login service that you want to be able to swap out for testing purposes. So your application code would basically grab the factory and call make, passing in a real login service, and the test code would pass in a fake login service, right? So this way you don't have to worry about which modules are published, which are internal. You can just kind of settle it at runtime, and it's fine. Now this doesn't scale really well. It can get kind of messy, but again, what we're trying to do is lower the initial cost of adopting Dagger. And so it can be a way of kind of setting things up so that people don't complain too much. And then as they get more familiar with Dagger, they can kind of switch to the canonical way of doing it. Alternatively, I actually find component dependencies a little bit easier to manage over these kind of published modules that Google wants us to use. And so what that looks like is instead of having a published module, basically you would have your application component, and that depends on a network component. And the network component is something that you could swap out for testing or application purposes. So the application code is going to look like this, where you create your Dagger network component and you pass that into the application component as a dependency. So that's your application code standard. But your test code could actually look something like this, where let's say you had a test application and you're going to initialize the application component, and you can pass in just an alternative implementation of that network component. You don't even have to use Dagger here, right? You can just say, like, this is just an anonymous inner class, and it's just returning this mock repository that can be used for testing purposes. And what's nice about this is that you don't have to subclass an application component. You don't have to worry about switching out modules. Instead, you're just switching out a component, and that actually makes the kind of the boundary of the things that you want to be able to stub out for your application very explicit. It's a component dependency, and anything that's inside of this component dependency could be switched. And I just think that's a little easier to follow than having all of these different types of modules. They're all modules, but you have to kind of maintain this implicit understanding of which modules can be changed and which can't. And so I think that's something that's worth considering to make the testing situation a little easier to swallow. Great. So we've just talked about kind of how to lower the initial costs of Dagger. That's basically it. That's the talk. Dagger 2 years later. Hopefully, the tips that we've covered here will help you not feel like this guy, well-intentioned, but also on fire. This is, we have a little bit of time. This is good. I have some bonus material I want to go through. This is my Twitter handle, and we'll come back to that in a second. Let's talk about what I'm calling some bonus features. Does anybody know the original reason for dependency injection? What was the original motivation? Why was Martin Fowler in particular really excited about dependency injection? Does anybody know? I didn't know this either. I think this is great. So, and this is going back to the part of the presentation where I talked about how can we get more mileage out of manual dependency injection by basically not using it as much. I think understanding the original reason for why it was basically created will help with this. So what Fowler says is a common issue to deal with is how to wire together different elements. How do you fit together, this web controller architecture with that database interface backing when they were built by different teams with little knowledge of each other? So built by different teams with little knowledge of each other. That's the key thing right there. That's the key motivation and the reason that the Fowler was really excited about dependency injection. And that's why he says, if you're just building these classes by yourself, it's fine if you don't use dependency injection. It's not a big deal because you can figure out how to wire these things together. It's not a big deal. So I think hopefully that'll make me seem like less of a heretic when I suggest maybe don't inject all of your objects. So that's one bonus feature. Another great quote that I thought was interesting that I came across in putting this presentation together is this one about mocking. I know people are concerned about dependency injection because they want to mock or stub. So this says, my personal practice is I mock almost nothing. If I can't figure out how to test efficiently with the real stuff, I find another way of creating a feedback loop. Does anybody know who this is? No? Okay. This is kind of obscure. This is Kent Beck. All right. So this is the guy, right, who is popularized TDD, for us. And he's like, this mock stuff, like I'm not that excited about it. And so if it's hard for you to imagine not using dependency injection heavily because you're really, really excited about mocking, just know that you're departing from like the guy who started it all, kind of. So you're the heretic. Surprise. Great. Let's see what else. I'm going to skip that. So I want to go back to this list for a second, the list of things that make adopting Dagger a little bit difficult. So there's this line here of basically where do I put these provides methods? And this actually is more complicated if you have objects that have weird dependencies in your code base. So, one of the things that I like to say is that Dagger is not really the main point. It's not the star of the show. Really, it's about your dependency graph. And Dagger is just a way of helping you actualize that dependency graph in your code base. And so if your dependency graph is jacked up, your Dagger usage is going to be more complicated. And effectively what you're going to do is you're going to enshrine your kind of crazy dependency graph in a bunch of code that's going to make it harder to change later. And so if you have code where you're looking at a class and you're like, why does this depend on a context? That's crazy, right? That's a sign that your object graph is a little crazy. And it's really worth thinking about delaying adopting Dagger in that part of the code base, because you're just going to have to change it later and it's going to be harder. Because you've enshrined that object graph with these modules and these other things that you're going to have to move around. So that's another bonus tip. We already covered that. This is another tip. I don't have an example of this, but this is something that I've seen people do when they start using Dagger, where they want every provides method to kind of almost have like a single responsibility. They don't want multiple news in one provides method. And I think that this just makes it harder to find out where things should go. If you have an object that's being newed up in a provides method and it's not being used outside of that method or anywhere else in the object graph, I think it's fine to leave it in that method. And in fact, I think it's preferable because it just makes it easier to figure out where to put things. Yeah. So that is it. A couple minutes fast, but yeah, that's it. Thanks, guys.